Well, guys, thanks for joining. We have Bill Cotter and Dean Weber, and today we'll be talking about rethinking our approach to securing brownfield devices, so legacy devices. As we were talking, Bill and Dean and I serve on the ISA 99 committee, and in those meetings it's often brought up, hey, we're working on all of these great standards for new stuff, but 70% of what we've got out there and our problems are coming from the old stuff. So what I wanted to do today was talk about that and talk about what's being done, what can be done, the pros and cons of it, and we've got two great experts up here to talk about it. So just getting started. Bill, you want to maybe talk a bit about
Introduce myself.
yourself? Yeah.
I don't know how many people have heard me talk before. I've heard myself, I guess. So see how much I got to go through again. But I've been around a long time. I'm originally a rocket scientist. I got a degree in aerospace engineering. Mostly did mechanical work, worked at refineries, a pharmaceutical blood fractionation facility, and then I moved to 3M. I've been with them about 37 years, so kind of covered that. So I was also in maintenance, so that's when I learned control systems, because it was always hard to get those prima donna maintenance ICS techs to stay late and do things. So I could do it with the mechanics, but so I had to learn the ICS end of it. So I did the bio plant and been working a while at 3M. I also was part of MS Mug, which led me into belonging to ISA 99. MS Mug was when we first looked at Microsoft operating systems on the factory floor and realized that this was going to be both a curse and a blessing. The blessing was now I could justify getting a IBM laptop and play Flight Simulator at home, or Doom, and then but it did lead to a number of issues on the factory floor, so we got a lot of different companies together to talk about that with Microsoft, and ultimately ended up at the ISA 99 talking about patching. And so I am one of the co-chairs of the patching document that's part of the ISA IEC 62443, which you've heard a lot about hopefully this week, and hopefully you get involved with. It's a good process to be involved with, so I would encourage anyone to do that. Don't wait for the end document and say, I'll read it when it gets published. That's forever coming, and a lot of good information already exists in the documents in the preliminary form. So strongly encourage, at least get involved in any standards policy to understand where the thinking is and meet some really good people. Because my company pays for my room, I feel some obligation to tell you about 3M, but also to give you an idea. Obviously I'm not a vendor, so an asset owner, and to understand the company. And it's probably a more diverse company than you might think about. You know Post-it notes, I hope you do anyway. Hope you buy lots of them. Scotch tape, obviously anything with the Scotch in the name is hopefully trademarked by us and controlled. But we make about 50 to 70,000 different products, depends on how you slice it. And we make everything from dental fillings and orthodontic materials, headsets for tactical police work and the fast food industry. We make nose cones for rockets. We make high tension power lines. We make sandpaper, and we do mining of some of the materials for roofing granules. It is a diverse company. And so we get involved with a lot of different processes and products. And any vendor who comes up to me and says, I'm selling something, I probably say, I've got it somewhere in the corporation. So we have lots of issues and lots of operations. We have somewhere in the neighborhood of 200 manufacturing facilities in about 60 countries. So pretty big company. It's fun to work for. And we have lots of openings. So I should probably get that out and make my supervisors happy. And these numbers are old, but it's a big company.
Dean?
And I'm Dean Weber. I'm the CTO for Mocana. Like Bill, I've been doing this for a couple of decades. And, in my career, I started in the Navy back in the mid-'70s doing physical and electronic security. moved into a little company called Western Union, working on projects like AutoDen and ARPANET. Had my own business for 17 years doing early stage computer design with multi-protocol routers, and then as security started becoming the S word, we specialized in internet security for government, federal, state, local, and large business in the Midwest. 9/11 happened, and some friends of mine in DC said they could really use my help with critical infrastructure. I sold my half of the business to my partner and went off and worked for Peter Tippett, who's the acknowledged author of Norton Antivirus, and had just been asked to advise the president on critical infrastructure via the PTAC board, and I was his eyes and ears out in the field. So I spent 2 years with critical infrastructure components, talking about what was coming, what 9/11 really meant to them, and how things were going to evolve for them. And then went out and did a couple of venture-funded startups on the West Coast, one called Teros, Application Security Gateways. We sold it to Citrix in 2005. It's the ALGs that are still in the NetScaler platform. And then another company called Applied Identity, which we sold to Citrix in 2010. And it's still the policy engine for all the Citrix backend products. And there was a whole bunch of other technology there that they elected to shelve. And then another friend on the East Coast called and said that he could really use my help with this little company called Computer Sciences Corporation. So I was a CTO for cyber at CSC for several years. Actually retired from there in 2015. And then this opportunity with Mocana came along, and I said, hey, that looks like something that would be a swan song for me, and I could really end on a high note and make a difference. So that's how I got here. Pretty much my experience is everything you can think of under the sun, including sun. I've worked on everything from highly classified environments to real low-level industrial stuff. So anyway, Mocana as a company is in the business of developing business solutions for industrial problem sets, using as a basis for that strong cryptography. And our ability to provide for security and secure elements on industrial platforms gives us a fairly unique perspective in the industry on how we can solve some of the more thorny problems associated with baseline security, updates, enrollments, certificate and key management structures, and Mocana does all of that.
All right. Great, guys. And my name's Keao Caindec. I head up marketing at Mocana. So let's just jump right into it. You know, the title here is about brownfield devices. But it's not clear to me that people agree on what that is. So brownfield devices, Dean, what's your perspective on what it is?
So I call brownfield anything that's deployed today going backwards, right? Anything that is existing in an environment today. We'll separate those into a couple of different categories in brownfield, but at the end of the day, brownfield means that it's already in use. Greenfield means that it's in the design or pre-implementation stages. Brownfield, from my perspective, is anything that is actually already out there operating in an industrial field.
And to me that, you know, I obviously don't read enough magazines anymore. Last night was the first time I have heard the term brownfield devices. So if anyone else is in the boat with me, don't feel so bad. That definition that we just went through leaves a little of the gap, because I'm almost thinking that greenfield stops as soon as I write the requisition, because it hasn't made it to the field. It's still being put together at the factory. It's got to be shipped and checked out and installed. So there's a lot of equipment that's coming in the door that is old even before I get to play with it. So it's great to have definitions, and you've got to get your vocabulary together. It's the first thing we do in standards, right?
Right.
To get vocabulary so we're all talking the same thing. But life is ugly, and there's a lot of grayness in it. So it's easy to say, oh, this is green and that's brown, but there's a lot of grayness in between. So.
Yeah, and I think there's also this notion of, are brownfield devices the things that just can't change, that are out there already, and what happens if you're able to change them? Or is there a difference between the two? And we'll talk a little bit about that later, but the key point is many of these devices have been out there a long time. They've deployed older types of security or almost no security at all. Can you talk about what you guys see out there and where some of the real gaps are beyond vulnerabilities published by CVE and ICS CERT, but tell us about these devices. What makes them particularly vulnerable?
Well, we used to be happy when things worked, and that was a very low bar. And it seemed like a high bar at the time, but just getting things to talk, it was all we wanted in the world, and to be able to go home. And I guess we got what we asked for, and they're still out there talking. They're fairly reliable and pretty solid. And so it leaves a lot. The world has changed. The bad guys have learned a lot more, and our devices have not gotten any better. And the newer ones maybe, but the older ones are pretty ugly for what,
Yeah, but why?
Even just scanning them, trying to find out what's out there can knock them over.
Right.
We prove that almost all the time. So.
But what makes them particularly vulnerable? I mean, what's the...
Marginal code, no factor of safety in the communications. No security thought of at all. I mean, simple, everything's in plain text. And,
yeah.
Well, we loved it because, I could put on an analysis, capture the transmission, look to see what commands are going back and forth, and loved it.
Yep.
Made it easy to implement, or easier to
implement, troubleshoot, yeah.
Right.
Know what's going on, so.
So, as things have evolved, then we started doing things like usernames and passwords, and then adding in more cryptographic services and cryptographic functions to a lot of these platforms. Obviously, the world has moved on, and we can get into a ton of the underlying causes, but probably the biggest one is connectivity, right? So instead of having to go out in the field and physically connect the meter to see what your analog signaling was looking like, whether you're getting your 4 and 20 milliamps or your 60 volts DC make break, or 24 volts DC, or even HART was an interesting overlay on an analog circuit. And we've moved way on from that, right? We've got a lot of, I think there's 36 different defined communications protocols for the industrial environment, only about half of which are associated with or ride on an IP backbone. But more and more, because of the ease of use function, again, trying to do more with less, right? If I don't have to have an operating engineer for every substation sitting in the substation with a manual at arms of what to do when what blinky light flashes, we're going to automate all of that. We're going to make it better. We're going to make it cheaper. We're going to make it faster. And that has brought us to the place where a lot of these systems that were never designed to communicate are now communicating with external components. And that's where the vulnerability surfaces really open up, is in the communications protocols. So when you have a username and password on your PLC and it's static and it was built from the factory and there's no changing it, what do? Right? How do you address that kind of problem when all of a sudden that device is actually addressable through the internet? And that's a kind of an extreme case. I'm not saying that that's the case in all places, but network connectivity is the ability of the back-end system to talk to the front-end system. That's what ICS SCADA is all about.
Sure.
At the end of the day.
Yeah, the marketing guys are saying, hey, we got to connect this thing up so I can sell my application management service, and it's connected to a network that has a bunch of vulnerable devices, right?
Well,
so
I think the business networks, the business guys have a lot to do with that too, because they want the data.
Right.
They want to run the business, so they want the data. How do they get them the data? We have to network the devices, because you're not going to put the business guys in the field.
So let's bring it down to something more concrete. Share a story that you have about vulnerability or the craziest sort of thing you've tried to seen done to protect a device or a vulnerability you've run into.
All right. It's maybe not the craziest story, but it's I think a telling story. It's one of my favorite stories of when we were moving from XP into Windows 7. was at a plant, and I found an XP device embedded into the process. It was a kind of a unique machine, made a very unique product. And I was all hot and excited, saying, oh, yeah, we got to replace this. And I could probably upgrade this system, with some clever approaches, and for about $30,000 to $40,000 or whatever. And the process engineer took me aside and said, look, we've got this, this product. We make no money on it. We keep it because it rounds out the product line. When that machine breaks and we can't fix it pretty cheaply, we're out of that product. So it really drove home to me and reminded me that I work in a manufacturing company. I don't have regulations pushing me very often to do something. First thing, of course, is always safety. And then the second thing is we have to make money. So we've got to look at the world and what needs to be done and balance it off with the cost effectiveness ratio that we can sell to the management. So that to me it really hit me that, how I get all caught up in technology, but no, we really got to be very practical about what we spend our money on.
Yeah. Dean?
Sure. So, little different approach. I'm a security guy, so that's my bread and butter. That's what I've been doing for 40 plus years. One of the things that I find unique about the industrial environment is the over-reliance on safety systems. Obviously safety is job one in any industrial environment. Risk is measured separately in an industrial environment from a business environment. Business environment, it's about profit and loss, it's about reputation, it's about financial standing and stock values. In the industrial world, it's about protecting process, protecting life. That's why safety is job one in the industrial world. But that's kind of been an impediment to better security because the process people believe that the safety systems are the end all and be all. They've engineered their safety systems to such a point where anything happens to the primary system, the secondary system takes over, or the safety system takes over and brings the process to a halt. And of course, the problem that they hadn't thought about is that both of those platforms are on the same network. And if you attack the network, then you're attacking both devices. We've had some presentations here on some of the problems that some of the safety system manufacturers have had this week. So, again, in the broad scope of things, to put it in context, the safety systems are not the end all and be all. We have to look at cyber, and cyber has to be close to job one. It may not displace safety, and I don't think it should, but it has to be up there. So there's a third leg to this stool that we got to bring into play. And I evidenced that by when I retired from CSC, I stuck my consulting shingle out. I'm going to slide into retirement gently, right? Not so much. And I got involved in an evaluation for a manufacturing facility of a large industrial function where they said, our safety systems have everything covered. We have no cyber vulnerabilities because our safety systems will literally take over under any condition. And my team looked at that and said, not so much. So we isolated a single point of failure in this industrial facility, which was a very, very large Drexel compressor. Many millions of dollars, built for purpose, no spare. And there were all kinds of redundancies around the control systems, but the physical compressor itself was a one-of-a-kind function. And so we engineered a solution by which the control systems were compromised. Both the primaries and the safety systems were compromised using a comparable compromise where we could attain control of both of those systems and we could pulse the compressor. So we went back to the process people and said, so what happens if we pulse this compressor? And they said, well, you'd burn it out. But nobody do that. I'm like, okay, so I'm showing you that there's a cyber attack vector here where we can pulse the compressor. What are you going to do? And they're like, well, the compressor's going to burn out. Yes, the compressor's going to burn out. What's your plan? Well, we'd have to idle the plant till we got a new compressor. I said, okay, so what's the lead time on the compressor? They said, well, from an engineering standpoint, it's about a year to build. And then they have to transport it, we have to install it. So I figure about a year and a half. And I said, a year and a half, that this multi-billion-dollar plant that you're running is going to be out of service. They're like, yeah, that's a bad thing, huh? So.
Well, I mean, and this is part of the issue, right? And why it seems like we need to rethink things. the business has pressures in both directions to contain costs and also to drive more services revenue or product reliability or productivity. And there's a reluctance to implement more security, perhaps, right? And what you're saying is there's a reliance on safety systems. I think a lot of the people in this room would believe there's a way to look at cybersecurity that relates much more directly to reliability, uptime, safety of the systems, right? Who's making the mistakes? Humans are making a lot of the mistakes, right? There's a way to use cyber to control what people or machines can and can't do. There is a way for us to, I think about technology and using it differently for safety and reliability. And it's important. When you look at what's happening now, the increase in threats and also threats that we see in the supply chain, I think it's more important than ever for us to get our arms around what we can actually do to not just build new cool stuff and put it in and around the plant, but what can we do to protect the devices that are out there. So let's talk about the change to the threat landscape. You know, we've had supply chain challenges out there, chips breaking down or being shown to be compromisable, and also concerns about components in boards. And of course, just the increase and fear that state actors are already broadly within our networks today. So let's talk about how that changes a threat landscape and you know, what we need to do.
Before I get into that, I guess I want to jump back to the safety systems and
Sure.
utter a phrase that I know some people will be upset when I say it, is that there is no safety without security. And so can you put one before the other and, you know, all that. We have great discussions about whether that's true or not true, or how do you look at it, but I certainly believe it. Everything's melded together, everything's gray, you know, there's no black and white. So I think that's very important in my mind, is that we need to do security because we don't have the safety and we don't have the operational reliability. The biggest problem I have for all this a lot of times is when I think safety, I have tables I can look up reliability and various other things. When I talk security, the thing I'm most afraid of is the thing I haven't seen yet. I can't predict this because somebody did so many ping attacks against me that I can decide how much I got to react or prepare for. So it's really a difficult world that we live in with this to justify and to think about security. How much security is enough security? How, you know, where are we going to focus on? Do I have a critical asset? Well, I got lots of critical assets. But, you know, if I lose one line, I got other lines. So we have to be, you know, we think a little differently than some types of facilities. Usually there's a train inside of a refinery that's the thing that you really keep going all the way. Mostly in my company, most of our things go up and down on a regular basis. We change product recipes and things. So I either want to protect everything or I don't have to protect anything. I mean, it's really hard for us to focus in my world, in the piece part manufacturing world, of what's critical, what's not critical, or where's things. And so when I look at the devices that are out in the field, you know, kind of back to what you were asking about, is that I don't know where to do it. So I have to work on a layered approach and treat almost all systems equally. And when it gets into the hardware and what can be done or what's coming at me when I open a box from a vendor, I got to trust they did it right. There's not much I can add on afterwards, except for firewalls and monitoring and whatever the normal things that people are doing nowadays, to know that I'm more secure. And I'll go, the next step is that I'm living in fear of IIoT. And these systems that people want to bring into our plants that run right up to the cloud, and I have no idea what the heck's going on. And I don't understand why that's needed. I don't know.
Yeah, I was meeting with an electric utility executive security guy. And he was talking about a very similar problem, trying to get his head around, okay, I've got all of these different initiatives that I could put in place in the substations to protect the equipment, to monitor them, to get more information on them. And he looked at it all and he said, but you know what? I'm most afraid of the physical attacks, which has changed the nature of how I think about our defending against a extended outage, right? And he said, I'd be better off just figuring out a better door lock that actually works for the substation huts, right? But it's come down to that, of really trying to think about what we can do very differently to defend against the attacks that we know are happening. Dean, what's your thought on that?
Well, you know, again, to Bill's point, we have to assess risk differently for cyber physical and cyber industrial. And because it has an impact on safety, reliability, you know, the ability to patch, right? One of the reasons why we don't get patches out in the field is we don't have a reliable way to patch, and two is we might have an 8-hour maintenance window once a year, right? It's hard to do a lot of patching in real time when you have a maintenance window that's 8 hours once a year. You know, so we have dichotomous processes that we have to deal with. But you know, overall, 62443 and NIST 853 R4, soon to be R5, and other industrial guidance is all coming back to the fact that the best way to address this is to figure out what is the risk, right? So when you classify your systems, whether you're classifying it through something like FISMA in a confidentiality, integrity, and availability model, or you're doing it in something in the context of 62443, where you're measuring the risk factor of what happens if this system gets attacked and what are the resources of the attacker, right? So if somebody's going to take down the door lock system to a closet door that is the closet door to the broom cabinet, who cares? Yes, it's a door lock. Yes, it's a security system. Yes, it's electronic. And yes, if it's attacked, somebody can get into the broom closet. Check. That's a pretty low risk. But at the same time, if that door is the emergency entry door to the data center, and you know, all of a sudden I've got access to, you know, raised floor controlled spaces through the same basic attack to the door, what happens, right? So we have to measure the risk. And once we have the risk measured, then we can determine, to Bill's earlier point, what is the appropriate level of cyber that we need to bring to bear. So the threat is evolving. You know, one of the reasons why 0 days are so scary is because there's 0 days, right? We've never seen this before. This is something new that pops up on the radar screen, the Reconyx attack, right? I mean, at the end of the day, that was a great example. Havoc was another great example of being able to bring in heretofore unknown vectors of attack that turn out to be deadly effective against a particular system or group of systems. And you know, when you think about taking this all the way out to the near peer nation state level, which is SL4 or FISMA high type environments, or even higher, right? I mean, the U.S. government's got lots of things that are above FISMA. Sure. But the idea there is that when you take the risk into consideration and you develop your control architectures, your security control architectures to supplement your safety systems as part of the overall design, that's great. The problem, of course, is brownfield, right? Where we've already got those systems deployed. They're unpatched or unpatchable. You know, the decision is, I'm going to take this product off the market if I can't keep this old system running. That's a you know, we in the right business in the first place is moot at that point. You're in the business. If you're going to turn it off, you're going to lose something, right? Some customer is going to be upset someplace, and it's going to impact your brand integrity. So what is the risk, right? We got to determine what the risk is. And in the brownfield world, this is where we start to separate brownfield upgradable from brownfield non-upgradable. And brownfield upgradable means that there is something we can do to address security, right? We can add the capability of enrollment, or we can add the capability of update. Those types of functions we can plug into these architectures because there's sufficient processing and storage space on these devices to actually be able to take supplemental functions on board. The brownfield non-upgradable means that you can't, right? There's no space. They were built for purpose, so the processor's running at 90% and the memory's running at 105%, right? We're swapping memory all the time. And we can't add anything to those systems because they were never designed to have any overhead extension. And that's where we struggle today, is right.
Or in some cases, you may not even have access to the application.
Absolutely.
Because it's not supported anymore.
Yeah, I mean, it's a 40-year-old application, right? It was written in RM COBOL. Who writes in COBOL anymore? I mean, don't get me wrong. I'm sure that there are people that do. But the point being is that sometimes just the antiquity of the device puts us in a position where we're not upgradable.
Okay, so let's deconstruct this, right? So let's assume that we have asset owners, vendors in the audience, and we want to take a look at what are the top things we should be thinking about or demanding when it comes to new devices for context that are being built. And then we'll dive into what can be done for upgradable and what do we do with the stuff that's not upgradable. So we've seen a lot of great presentations this week on different technologies that can be used. What are the things that you guys think are the most important approaches that companies should consider for either new deployments, new equipment, whether technology or other services out there for new stuff?
Well, keeping it in relation to the conference,
Yep.
one of the things that I've fed back, and that I enjoy these conferences when there are some talks by hackers and some obscure side channel attacks and that kind of stuff, because even though I'm not going to do that, or I don't really understand it all, it does help me look at new products that are being built. So when a vendor comes to me and they say, oh, we're secure, I have a little bit more intelligent questions that I can ask them about it. So I really enjoyed those parts of these conferences because we get into understanding what I need to be looking at from my vendors. So otherwise, I just have to take their word for it. So that's always, a dilemma for us is how do I know? They all say, oh yeah, we're secure and we've got certificates. Well, who signed them? Where'd they come from? We don't know. I mean, how do I really understand all that? So it leaves me with a dazed look when some of these talks happen and that kind of stuff. So new items, and the only thing I can ask for, and I mentioned it with the IoT, is that I don't want things to be black boxes where I can't monitor, I can't understand what's happening. Because if they immediately talk to the cloud all encrypted, well, that's wonderful, right? It's encrypted. So, but that means I don't know what's going on. I don't know what's going up. I don't know what's coming down. So to me, I always want to have some way that I can monitor what's happening and do it. So I'm looking for that in newer devices, is that I want to make sure that I still have some responsibility to the plant, or that we can say, yes, things are running normally or not running normally, or know what's going on. So looking for capability of having visibility to me is very important for the future.
And I agree with that 100%, right? But again, that's moving towards the concept of new.
Yeah.
So the things that you're asking for are cyber resilience. The things that you're asking for is tamper resistance or tamper proofing at all levels of the control architecture.
And that, to me, is greenfield.
We're agreeing 100%.
Yeah, we're definitely in greenfield there.
But what can you do with brownfield, right? So again, in the brownfield upgradable world, we can start to add things like strong identity, right?
Go into that a little bit more, because give an example of what a brownfield upgradable is and what you do to it.
Okay, so we've got a PLC that's currently a adjustable username and password as the sole access control mechanism on the platform, but it's running a modern RTOS on a relatively modern processor architecture, and has sufficient storage and operating headspace in memory that we can add some function, right? There was space left on the platform for future capabilities to be added. One of those capabilities that we could add, and most of the modern RTOSs have some level of certificate storage, right? Meaning that we can have a secure space, hardware, firmware, software, depending on the level of device and the threat that you're trying to resolve for. But you have some mechanism by which you can install via an installation process, a unique, strong identity, an X509 certificate.
So a firmware update to the...
Could be firmware, could be software, right? Because again, Windows, Linux derivatives, most of the RTOSs have secure facilities for things like credentials, right? Because they were built with that in mind for the commercial space that have been adapted to the industrial space.
And not utilized on ours.
And not utilized today because we have a username and password in the Etsy password file someplace that's hashed.
Yeah.
Right? Not very strong
Hopefully
to begin
hashed.
with. Hopefully hashed, not clear text. But again, the idea there is that we have very little in the way of definable security, but we have the capacity to add stronger security to the platform. So I guess that's the differentiator for me, is that if we have the capacity to even add a certificate, and if you watch any of the presentations that we've been involved in the last couple of days, certificates are one of those things that you take for granted, right? They're hard to manage. Nobody really understands them. Nobody really wants to get involved in PKI and all the things that are back-ended by PKI. But if we automate that process and we make it easy, we can actually add significant security to the platform just by giving it a strong digital identity and then leveraging that identity. And what do you leverage that identity for? Well, you talked about patching, right? We have a patching problem. We have an update problem, right? So today we don't do a lot of updating in the industrial spaces because we can't validate that we're updating the correct thing. We can't validate that the update came from the right place. But with modern cryptography, we can. And when I have that digital identity to base it on, right, I can actually encrypt a package that is only going to be decrypted by that system once I have a digital identity on it. So now I have the ability to not only identify the device using a strong digital representation of who and what that device is. I can associate all kinds of things like versions, like platform processing power, like network protocols. I can associate all of that with that strong digital identity.
Right.
And once I have that identity, then I can start layering on additional things like secure update and secure patching.
And mostly this would be, I have to get my vendor to buy into that, or I download, check out the updates, and then I do all this within my facilities.
So it depends on the platform, right? If the platform is vendor specific, meaning that you don't have access to the operating system or the file system, and that's part of the package that you bought, and you buy maintenance from them and they do that work for you, then yes, you have to get the vendor involved. But if it's an open platform and you're running a Linux derivative that you in-house built for a specific use or function, you guys have built a specific manufacturing process, so you built a Linux-based RTOS on your own using one of the Linux derivatives, and that's yours. You have control.
Yeah, then we have open.
You can add that yourself. So
Pendulum swings back and forth on when.
The answer to your
we're doing
question
those
is it
things.
depends on what the platform is, whether or not you can do that or not. And again, that all comes into the equation of what is upgradable and what is possible and upgradable versus what is not upgradable and what is not possible. If the vendor's out of business, right, or you're running XP, yes, you can pick up the phone and spend $40,000 a year with Microsoft to have them continue to support that for, like the United States government does. Right? Keep XP alive. But if that's not a business reality for you, what are your options? Right? We need to have other options available to us. Some of those can be on platform, some of those can be near platform. Right? Isolate the platform, gateway service. So if you listen through our ABB presentation, one of the things that we see the device manufacturers, the industrial manufacturers doing pretty much across the board is the concept of gateway services, whether that's edge gateway, which is the PLC replacement, greenfield, or whether that's gateway as intermediary, meaning that you're keeping those systems that are unsecure or insecurable, right? And you're putting something in front of it that is securable as a proxy, if you will, for access to that in an industrial environment. And both of those things are alive and well today in terms of the vendors. The vendors recognize that, one of the big things about industrial is age, right? These systems are designed to operate as designed for decades.
I always hope so when I buy them.
20, 30, 40 years. Right?
We still got them.
I know you do. So that's a problem, because something that was designed 40 years ago isn't even running a modern language.
No, we adjust it by adjusting capacitors and resistors.
Right. So what I'm hearing is there are ways to upgrade the strength of the identity as well as maybe the certificates on the device, without necessarily touching the application itself, which is updating that piece, right? There are also ways, if you have access to the application and you're working with a vendor, you can go in and perhaps add new features to that to add more security to it, right? We've seen that in doing things like implementing or replacing DMP3 with DMP3 secure authentication as a more secure protocol, adding in extended authentication for passwords, at least tying it to
or
a radius server.
OPCUA or whatever
Adding
it is.
in SSL or some, but it's all a small change to what that system can support, and there are ways to do that. And then there's the other approach of, can you add something to that device to solve the larger problems around managing the certificates more easily? We hear this over and over. Hey, great idea, certificates, but asset owners on the OT side just aren't used to managing at that type of scale because certificates have been more on the IT side, right? And it's complicated. So I think there are ways to do it, and I know, even with the FDA, we're working on some really relevant programs to upgrade security without touching the application to avoid an FDA recert.
Right, because that's expensive.
Because it's expensive, right?
Well, and in some cases, more than just expensive, right? I mean, it would, if a failure exists, it would be a cease to use order on a particular medical piece of equipment. And when you think about injectables and insertables and implantables, there's a reason why they turned Cheney's wireless interface off on his pacemaker.
Right.
There's a more recent example of the wireless interface was actually the vulnerability of the platform, and several tens of thousands of people who had that particular piece of technology implanted in their bodies had to report to the hospital for upgrade.
Right. Yeah.
Right? So, I mean, these are the kind of things that we're seeing become reality as the state of cyber attack and the state of cyber defense marches on.
So we have a few minutes left. Let's open it up for questions for people who have, some sort of complex issue or question around their own environment or products that are in place already, and how you might approach protecting them.
Someone, are there
Oh,
mics?
yeah, go ahead.
So I understand the value of the following IT security improvements have been installed. Is there value in rethinking a security scheme, for lack of a better term, that better matches the OT environment? Is it worth building something special to get the features that might make more things upgradable brownfield as opposed to non-upgradable?
Well, the one thing, that the first thing you hear for almost every talk, and these things are the common thread, is segmentation. A lot more segmentation in the ICS world or the OT world compared to the IT world, and then of course building in some sort of strong firewall rules for the isolation. I don't know if that's what you're getting at, but the old Purdue model, which I think is great still as a reference, even though we yell about whether or not it's still viable or not. I still think it is. So did that answer go to your?
Let me take a different whack at that too.
Okay.
So
Yeah.
the fundamental problem is multi-tiered here, right? Number one, OT security is brand new, right? We don't have lots of expertise. We finally filled a lot of the expertise in the IT world for cybersecurity, but OT security is different because of some of those reasons, because of segmentation, because of the ability to access, right? Generally, IT systems are not built in isolation along 1,000-mile pipelines, but there's a lot of sensors, OT sensors, in 1,000 miles of pipeline that have to be accessed, and the input from them has to be brought into consideration. Temperature, pressure, flow, gravitometer, specific gravity. All of those things have to be brought into the concept of, is the pipe operating at optimal efficiency? Is the contents of the pipe what I expected to see? that you don't get that in the IT world. So while some of the IT methodologies at the perimeter are certainly valid, separating the IT from the OT or separating the OT from the internet, or providing sufficient controls to allow very unique and explicitly controlled access via the internet, the end of the game is, you know, if you're going to go out and you're going to update the flight control system on the flight line, you have a different problem than an IT problem, right? This is an OT problem. How do I bring that update onto the platform?
I think there's some interesting things we're doing also. For example, with Intel and other partners to look at fundamentally changing things. So moving to more zero-touch enrollment of devices, much more secure, much more scalable. The challenge is a lot of the IT processes just don't scale into securing, enrolling, activating, deactivating headless devices at scale. So I do think we need to rethink it, and some of that will make it into new standards, and some of it will make it into new tools that we need in OT. With that, I think we're out of time, guys. Okay. So thank you very much for joining us, and have a great rest of the show. And thank you very much, Mike and the guys at the conference for having us.
Thanks to the audience for staying.
Yeah.
Nice to talk to someone.